everyone, it's Coach Fred here, and I thought it might be smart for us to do a quick video on factors. So I don't want us to be afraid of simple words when we look at the SAT or the ACT for that matter. You know what the word factor means. If you took Algebra 2, then I know you can factor. But let's look at the basics of the word, okay? So what is a factor? A factor of a number are numbers that multiply to give you that number. So for example, 24, okay? 24 has several factors, but 2 and 12 are factors of 24 because they multiply to give you 24. 6 and 4 are factors of 24 because they multiply to give you 24. Now, it gets a little bit more confusing when we look at a polynomial. Say we look at something like x squared, how about plus 3x minus 10? You've been asked, over the years to factor that polynomial, and all that means is to break it up into things that multiply to give you that polynomial. And so here's a great example. This would factor to x plus 5 and x minus 2. Again, when we factor, we're looking for factors that multiply to negative 10 and add to positive 3. So this is in factored form. Now, factors then lead us to solutions. They lead us to solutions. So if I'd given you this polynomial, and the polynomial actually was set equal to 0, then we would put it in factored form, and then we'd use the zero product property to solve and find the solutions. So x equals 2 and x equals negative 5. Those solutions represent the x-intercepts. Remember, when we're finding solutions of a polynomial, we're finding the zeros, the roots, the x-intercepts. So in this case, negative 5, 0 is an x-intercept, and 2, 0 is an x-intercept. So I want you to look at the relationship between those solutions or x-intercepts and the factors. Okay, this one's negative 5, but the factor is x plus 5. This one's 2, but the factor is x minus 2. On these tests, they often like to ask you which of the following could be factors. And you'll have to look for x-intercepts. So look for the y-coordinate of 0. All right, so how do we find factors? You find factors by factoring, which I did. We can also find factors by doing polynomial long division. So if I gave you x squared plus 2x plus 4, I can find factors divided by x plus 1. I could find factors because if it's not factorable, by dividing. So I could do x plus 1 into x squared plus 2x plus 4. All right, so let's look at that for a second. Let's see what happens. As a reminder, polynomial long division, I'm really basically just doing what we would do if we were doing long division. So I say x times what gives me x squared, or how many times does x go into x squared, which would be x. I like to line it up right above the term that has the exact same exponent. And then I multiply the x to the x plus 1. That's going to give me x squared plus x. Then I subtract, so I'm going to change the signs. So I add down, and that's going to give me x. Bring down the 4, so x plus 4. So x goes into x one time, so I get x plus 1. And that's going to give me x plus 1. I subtract, so I change the signs of everything, and that's going to give me 3. So since this is a remainder, x plus 1 is not a factor. Now, it doesn't mean it doesn't exist. I will tell you that the point, I take the point negative 1. I always take the opposite value for x. I know that the point negative 1, 3 exists on that polynomial. So if I were to graph it, I know that negative 1, 3 is on the graph. But I know it's not a factor because I didn't get a remainder of 0. Okay? So those are a couple ways to find factors. You can also think about it. Here I give you a table. So here's one example where I give you a table. And I might ask you, what are the possible factors? And I could say something like this. X plus 2, is that a factor? X minus 3, is that a factor? X minus 4, is that a factor? X minus 8, is that a factor? Well, if I'm looking for factors, I'm looking for the x-intercept first to work backwards. And I can see that this is an x-intercept. So then my only factor here would be x minus 4, okay? All right, in this one I give you a graph. And I might ask, what's a possible equation of the graph? And I might say polynomial because it's a polynomial. What's the possible equation? So first, I see that my x-intercepts, I've got 3 of them. I've got -2, 0, and 2. So I write them as factors. So this one would be x plus 2. This one would just be x. And this one would be x minus 2. So I can just make that y equals, and I've created a polynomial in factored form. If I wanted to get it into standard form, I could just multiply those terms. All right, so that's kind of how we think about it. Lots of ways they could ask it on the SAT, and they might not use the word factors. Here's a good example of thinking about it with notation. If f of x is a polynomial and f at 3 is 2, can you say that x minus 3 is a factor? Well, this is the point 3, 2. Remember, function notation is just a way to represent coordinate points or to represent inputs and outputs. So 3, 2 is not an x-intercept, so that means that x minus 3 is not a factor. And that could be why, why or why not, because the point 3, 2, it just doesn't give me enough information, and 2 is not 0, so it is not an x-intercept. So hopefully you're seeing it really is not that hard of a concept, but you really have to think about the word. All right, here's a typical problem on the SAT. In the xy plane, the graph of the function has x-intercepts -3, -1, and 1. Which of the following could define f? So basically, it's just asking you which of these is a possible equation. So take your x-intercepts and write them as factors. So x minus 3 would have to be written as x plus 3. X minus 1 would have to be written as x plus 1. And 1 would have to be written as x minus 1. So I took my x-intercepts, I wrote them as factors, and I made it a function. And so I would be looking for C as my answer. All right, guys, hopefully that was a helpful video on the idea of factors for the SAT, and I hope that it helped. Have a great day.